In order to characterize each point x sub I, we introduce variables epsilon sub I, called slack variables, for each xi, where I ranges from 1 to n. If xi is on the correct side of the hyperplane, but inside the margin, like this, then xi protrudes into the margin by a certain fraction of m. So epsilon sub I is the fraction, and it's between 0 and 1. The distance between xi and the hyperplane is given by this distance here, which is m, minus this distance, epsilon sub I times m. Okay, so let me write that here. M minus epsilon sub I m. Factoring the m out, we get this. However, the distance between xi and the hyperplane is given by this, so that's equal to m times 1 minus epsilon I. Solving for m, we get this here. If xi is on the correct side of the hyperplane, but on or outside the margin, then xi does not protrude into the margin by any amount. So here xi is on the margin here, and this xi is outside the margin. Okay, in this case, epsilon sub I is 0. The distance between xi and the hyperplane is this. Okay. And the distance between xi and the hyperplane is greater than or equal to m. As you can see here, the distance between xi and the hyperplane is either equal to m here, or it's greater than m. Okay, so this expression is greater than or equal to m. We can rewrite this as 1 over the norm beta times yi times this, times 1 over 1 minus epsilon I is greater than or equal to m. Okay, because epsilon sub I is just 0. Okay, so this is the same as this.